let's get this rolling here. Let's open up the meeting of April 4th, 2023. Call to order, Commissioners Public Forum. Anybody here from the public? All right,
No.
hearing nobody. Let's move on to the warrants, minutes, and abatements, please, Cam.
All right, first I'd like to make a motion to approve the minutes review of the March 7th meeting.
Do I have a second?
Second.
Roll call, discussion. Roll call vote, Peter.
Mr. Coleman,
Aye.
Mr. Jennings,
Aye.
and Mr. Cantwell.
Aye.
All right, and then moving on, I'd also like to make a motion to approve the review and signature totaling $124,164.09.
Second.
Discussion. Peter, roll call vote.
Mr. Coleman,
Aye.
Mr. Jennings,
Aye.
and Mr. Cantwell.
Aye. Moving on. Peter, scheduled appointments. 6:35 Veolia monthly report.
Yeah, Vinny's on the line to give us the monthly operating report for February.
All right, everyone, we're going to be covering February of 2023. The plant was fully staffed by myself, Grant Krisiak, and Kurt Hoyle. On February 1st, we completed Veolia's monthly inspection report. We also built a concept safety wall. That's a new program Veolia is rolling out. It's somewhere to display our goals, achievements, and safety standards. The training for the month was electrical safety for unqualified employees. We also did lockout tagout for affected employees and lockout tagout for authorized employees. Compliance for the month of February, there were no exceedances. The DMO was completed, entered into the CDX on March 15th. And first quarter toxicity was completed and the plant passed. We received a notice from the DEP. It was for non-compliance for the year 2022. We had a whole bunch of exceedances last year, and some of them were from mechanical failures, some of them were for coagulant issues and the SCADA upgrade. There were just a lot of things that compiled into it. The only thing the notice asked us for was to make the repairs needed to get the plant back in compliance, and we had already done all that. So we wrote a letter explaining we were in compliance. Veolia's technical team reviewed it, said it was okay to send in. So we sent that response to the DEP and the EPA. Operations and maintenance activities. We drained EQ tank 2. Slim Sewer Service came out, they cleaned it. There was almost 3 feet of thick sludge in there. When they cleaned it, we were checking the valves and we noticed one of the valves was broken 3/4 of the way closed. And then the following day we cleaned EQ tank 3, and EQ tank 3A also had a valve broken closed. So this is why the EQ tanks have been having trouble getting the flow through them. I don't know if you guys remember, but in previous months I had mentioned they were bubbling at the manholes and stuff during heavy flow events, and that was the reason why.
Are those the big red valves that are on the ground, Vinny, by the tanks?
Yes, sir. So what we did is, while Slims was in there and the tanks were empty, we actually took the broken valves out. So there's no valves to stop the flow to the pump pit. And yes, right now we have brand new valves on pallets out in the yard that are ready to go back in place. That project, we'll be getting going on it in probably the next month or so. It's a big project Slims will be coming in to do. It's probably going to take a couple of days, so we're just looking to coordinate the time. When we purchased those valves, we did reach out to several different vendors, and we opted for the one with the best price. The best price and availability. We started doing the annual SDS update. Those are the safety data sheets. We actually built 3 binders full of safety data sheets. We have a lot, but they're all up to date and up to the standard they should be. The bathroom floor, the epoxy was all flaking off, and it's kind of been a nuisance for a long time. So we took the effort and scraped as much of it off as we could, so we don't have that issue anymore. We cleaned and calibrated all the plant pH probes, and those are just for monitoring and process control, but it's nice to have them working the way they should. The UV system received its annual bulb and sleeve replacement. The system was turned on and we did a test run just to make sure we were going to make compliance, and all the tests passed. We're still monitoring the UVT daily, and that's basically a test of the clarity of the water just to make sure the UV can penetrate it. Let's see, sludge pump 3 broke a drive coupler and we ordered a replacement coupler. And sludge pump 2 started leaking at the seal. These are the pumps underneath the Comag tanks. There's 3 of them in total, and they're really designed well as far as we can use one pump to do the job on both trains. We can valve it to run in any position, so we're still okay even though we had problems with 2 of them. The effluent sampler, it started collecting incorrect amounts of samples, and it was caused by a faulty float switch, and it was also having some electrical issues. We ordered a replacement for it, but in the meantime we borrowed one from one of the MTAs. The alkalinity analyzer, Hawk came in and did their last maintenance on it. They did quarterly maintenance on the alkalinity analyzer, and after they were done, it just kept reading off by about 500 milligrams per liter, which is a huge variance. I mean, we typically report up to 100 milligrams per liter, so to be off by 500, it was noticeable. We spent the day working with Hawk Tech Support and recalibrated the unit and got it working the way it should. We had an issue getting caustic, so the team and I set up a tote. We mixed soda ash into a slurry, and the slurry helped us maintain compliance with pH. We drained and cleaned the plant water tank, and after we were done with that, we added hypo for disinfection. So that's sodium hypochlorite, and we have a dosing pump that just doses in a small amount all day. It's almost non-detectable, but it's enough to keep any bacteria from forming. We fixed the headwork screen washdown feature, and what that does is it just basically washes all the rags before it packs them together. And after we got that operating right, we started getting a more consistent amount of rags out of the unit. There was a windstorm during the month of February, and during this storm, a limb fell off a tree in the driveway and knocked the power out to the plant, and there was a fire on the edge of the driveway. This was after the tree service had already cleared about 3/4 of the driveway. This was one of the last big pine trees along the edge of the road. Let's see, we're at the collection system activities. The MTA samples were collected on February 1st and the 19th. Pump station activities, all weekly pump station rounds and tests were completed. Back to that windy day, a tree fell on Stafford Street, taking out the power. And we went out and checked the pump station while it was out of power. It was running on generator fine. A couple hours later, we went back to see if it was restored. City power was back on, but the generator was still running and the level system wasn't operating right in the pump station. So we called LaFleur Electric out, and they told us we should check out the big fuses out on the pole. They were fine. So they came out just to go over things and see why we couldn't use the level system. And while they were en route, they were almost there, we noticed at the intersection of Stafford Street and J. Hammond, there was a blown fuse. So we called National Grid to get that taken care of. LaFleur came out, they made sure the bubbler system was doing what it was supposed to. They got everything just checked over real good for us. The power came back onto that third leg of power and everything worked. The phone line died again at that pump station. This is the second time, but we notified the phone company and they were out there quick. It was repaired within a day. We took 5 loads of sludge to Cranston for disposal. We received 2 totes of sodium hydroxide 25% and 3 skids of soda ash. Grinder pump calls. On February 7th, we were at 65 Old Worcester Road. It's an old system. We just cleaned the sensor and it was good to go. On the 18th, we were at 62 Vine Street. There was no alarms. The customer complained about sewer backing up into the home. We pulled the cover of the grinder pump and it was at a normal operating level. It wasn't high or anything. The pump ran the way it should. So it was clogged going out to the grinder pump and we informed the homeowner of that. On the 20th, we went to 35 Sunset and we put a new grinder pump in. Some special notes, Wright Pierce was at the plant and during the meeting, we discussed the big influent flows during rain events. And they really went over a whole bunch of different options, replacing all the piping through the whole plant. And at the end of it, it was concluded we should just stick to the original design features of the headworks being capable of 2 million, but the rest of the plant is still only capable of its peak flow design. We also installed a new water meter at 96 Park Road. And that concludes the MOF for February 2023. Anybody have any questions?
Sorry, Vinny, I was on mute.
I thought I was for a minute.
No, nothing for me. I have no questions or anything. Anybody else?
Nope, I'm
All right,
good.
thanks, Vinny. Appreciate it.
Vinny.
All right, thank you guys. Have a good night.
Moving on, Peter. Beta.
Yes, Chris and Andy Denny are here from Beta to talk about the water model update that they did. I believe there's a draft report here for your review, and they're here to kind of give you an update on that. And after that, Peter Newton will be here to talk about the water drilling update on the Santos property. So with that, I'll just turn it over to Chris or Andy and see who wants to kind of walk through what they did and what they found.
Sure. Thank you. Thank you, Pete. Yeah, so we met, I think, 2 or 3 weeks ago. Since then, we've updated the model. We were able to replicate some of the transients that the system itself experiences, which is great. It was a little bit of a tough go on that, but we were able to do that. So we began to model different scenarios. And I think in the report, and I can share that if it's helpful, Pete. Do you think it
Sure.
would be?
Yeah, I think so.
Just give me 1 second here. So we modeled 3 different scenarios. One is obviously your existing conditions. And that's with Hammond Hill Tank online. The second one was utilizing the Charlton tank off of Route 20 with no other system modifications. And then using that Charlton tank with some modifications, which would be the reactivation of the 12-inch main between Northside Road and Old Worcester Road. And then a dedicated inlet and outlet piping for that tank. So what you can see here is, I think the biggest, well, there's 2 things here, right? It's water age and your pressure transients. Scenario one, you can see those transients. They're fairly significant. And then you have your water age here. We did not see much of an improvement activating the Charlton tank without any other modifications. But when we did see, when we modeled those other modifications, which is a dedicated inlet and outlet to that tank, as well as activating that existing 12-inch, we do see the pressure transients calm down quite a bit. With this scenario, we would be retreating the water at that point. And so obviously the water age is much improved. So those are the three scenarios that we modeled. We're comfortable that we have got the model to replicate your system. I think one of the big takeaways from our effort is that both the system and the model are very, very sensitive, given just the geometric alignment of everything. It's very, very sensitive, which we found, which I think you guys have found in the real world. So we have some options for you guys to explore. I don't know if you've had a chance to take a look at the report. I think the only thing that I'd like to touch on outside of that is just the immediate issues you're having at the Bay Path pump station. And again, this station and its location and design did not cause any pressure transients. However, given the location of that station, you do see some transients that go very close to zero, and some of the fail safes that they've had to program into that station, I think are resulting in those pumps shutting off and needing to have somebody physically go there and reset them. So, you know, we have a discussion here, although that, you know, again, the location and that station itself are not causing those transients. The location of it is, I think, somewhat problematic given those transients. So I don't know, Chris, if you want to add anything. Chris was our modeler on this, so he really did a deep dive.
Yeah,
So-
I mean, I would say the biggest takeaway, like you said earlier, is the sensitivity of the system. You know, based on operation of check valves at pump stations, and we were able to like modify them within the modeling scenarios. You know, changing them just slightly can really reciprocate out huge pressure transient waves throughout the system. And we just wanted to really make that evident in our findings and in recommendations, that if you're ever running, you know, or making any operation changes to the system, whether that's running, you know, changing gate valves or running a hydrant or shutting off PRVs or making any modifications, that, you know, you operate them as slowly as possible. Make sure any pump station variable speed drives have a soft start and shut down, and that the PRVs in the system are actually operating as designed. I think those are the key points that we wanted to also emphasize.
So we'd be happy if anybody, you know,
Yeah, any
have any questions or, you know, you don't have to get those to us now. If you want a chance to either read the report or digest what we've talked about tonight, that's fine. I know that there was a question, Pete, regarding the hydraulic grade line.
Yeah,
And pressures of switching two different tanks. Just to kind of clarify that, in the model, we set the operating points of both of those tanks to the same elevation.
Understood. That makes sense.
Yeah.
Right, so and we can certainly model if we take the Hammond Hill tank offline and we use the Charlton tank, we can certainly change those settings. I think you're gonna see a slight increase in pressure if we do that. I don't think you're gonna see any resolution of transients or water rage. In fact, depending on how it operates, elevating that tank's off will could affect water rage, but it shouldn't be in any major way.
So just to clarify, in scenarios 2 and 3, where we talk about activating the Charlton tank, the J Hammond tank will be offline at that
Right.
point, correct?
Yep, yeah,
Okay.
correct, yeah.
And in your scenarios 2 and 3, you set the same elevation at the Charlton tank as at the same elevation of
Yes,
the
yeah,
J
because we
Hammond
weren't,
tank.
we weren't certain,
Yep.
at what, in the future, if you change that to be higher or not. We just wanted to get a basis of if there would be any major impacts to the system.
So looking at the issues that we're having with our system with the transient pressures, the pressure fluctuations that we can see in scenarios 1 and 2. So scenario 2 alone, bringing the Charlton tank online will not give us much of a benefit at all, if any, with the issues we're having.
Correct.
Right.
Yeah, the dedicated inlet and outlet in scenario 3, I think
Yep.
probably has a decent effect on those
Okay.
transients. And if
Yeah,
you would like us to split out, that scenario to activating that 12-inch main without separating the inlet and outlet,
No,
we
No,
could also do that, but
I think what we have here in scenario 3 works.
yeah,
In my mind, I think we would do what we had to get a dedicated inlet and outlet to the Charlton tank
yeah,
Mhm.
you would want that
And-
regardless.
and operate that without activating Route 20 main to start to make sure that it operates as modeled. And then if we do see it working that well, we could try and activate the Route 20 main after to make sure it doesn't create any water age analysis, any water age issues then.
Yep.
So no, I appreciate you guys getting this done. I'm glad we kind of have a solution. So other than these 3 scenarios, is there anything else you think that should have been considered to create a solution for what's happening?
We looked at or we discussed providing a loop from
Masonic Home, Route 20.
yeah,
to
Masonic
Home?
Homes down, but I think given the fact that we found what we think is a solution here, cost wise, that it didn't make sense to really include it. I can't imagine.
Yeah, I'd be worried that that could actually exacerbate, the situation, because it's not like creating a specific break off in zoning, for that system. Because it would almost be bypassing, the main booster station up to the tank, if you know what I mean. So that could send, waves out even through a longer line versus, stopping it up at the tank if there ever were any transients in the system.
Yeah, agreed. So I think to answer your question, Pete, yes, we did look at a couple other things, but we didn't consider them to be viable, either cost or, practically.
So I guess from here, how much would it cost us to, Andy, can you stop sharing your screen so
Oh,
I can
sure.
just make
Yep.
sure that nobody else? The. So I guess from here, could you guys get us a cost estimate on what it would be to initiate scenario 3 for that dedicated? I mean, I measured it online. It looks like a quarter mile, just about 1,400 feet to go from H Putnam Road over to the existing tank if we get that easement, and then install that PAX rechlorination system.
Yep,
And I think really add a valve, it's really not a huge lift, but just trying to get some idea of what that cost might look like, so we
Yeah.
can kind of have that to consider.
Yeah, so I think it would be activating that tank. There's a cost associated with that.
Yeah.
And then the actual infrastructure. Yeah, we could certainly get that cost to you, and then would you like that included in this report?
Yeah, I mean, if you could
Okay.
just, if it's not that big of a lift and you can get that done and add that to this report. Again, without activating the Route 20 main for now, just
Yeah,
operating what is, because yeah, to look at how those pressure transients go away, and if those pressures stay that steady and that water age stays there, I think we'll hopefully be in great shape where we won't have to run a blow off anywhere. So it'll solve kind of both of our problems, which is the transients causing the low pressure up at the Bay Path pump station, and then the water age causing the blow off down at the middle school. I
Yeah,
guess my last question, I guess real quick, in scenario 3, I wasn't sure if it was a big deal, because if water age starts at day 0 at the tank, if we run that old Worcester Road loop in a directional flow configuration, what that would change for the water age, because the middle school wouldn't be the end of the line, the overlook would be.
we can definitely look at that.
Yeah, so you would have to go from, say,
would co- it
the
would come down-
tank to north side, all the way out to Old Worcester Road,
Nope.
and then down that way instead?
Nope,
Is that what
no,
you're saying?
No,
Oh,
it
okay.
it would go from Route 20 down North Main Street to Old Worcester Road. Head
Okay,
east on Old Worcester Road, and then loop all the way back around and come up Mugget Hill Road to Main Street, and then head out to the overlook. And again,
yeah, we can talk about that.
we can
side.
talk about
Yeah,
that offline, but
Okay,
that just a different way to see what that does with water age. Again, because the overlook is the largest user there at,
Right.
45,000 gallons a day,
Right.
so.
Yep.
yeah, they'd be pulling a lot of it. Yeah,
Yeah, they draw pretty much all of it.
yeah.
And I would just be curious to see in that directional flow, kind of how those water ages might change a little bit.
Okay. Yeah, we could definitely talk about it.
Yeah, so again, when you guys start to look at that, let me know, and then
Sure.
again, just the valves are already in place to do that. Those were put in as part of this, as part of the school loop project. So
Okay.
we can do that currently now. It's just with the current transients to go in directional flow, so it doesn't get the bay path from either direction. It's even more sensitive than it is now, so they have the issues are greater with that pump station hitting 0 PSI.
Right.
So, no, I appreciate this. This looks promising. And again, to me, this looks promising, and it looks like it's a truly viable solution to kind of help our system work through some of the growing pains we're seeing. So I appreciate it, and I'm glad we kind of found something that might work.
Yep, agreed.
Yeah.
Again, I didn't mean I don't know if anybody else on the commission has any questions or thoughts.
No, I would like to see that as well, the directional. And wasn't that the original plan, Peter?
Yes, it was. But again, we tried to run it in that directional flow. And I think, the Bay Path pump station, they lost water there 3 times in 2 days because it just made
Yep.
it that much more sensitive. So
Mhm.
we're actually hoping that with the hydro-pneumatic tanks that Kleinfeld or ExxonMobil put in, that we can try and run it in directional flow again. And I think I talked to Steve Gregoire, and we're thinking about doing a trial run for that over school vacation week in April, when Bay Path won't be using much water. So we can kind of test it out then before we get into summertime and they start running that blow off down at the middle school.
Yep.
So,
That's really that would be the last bit of information that we need before we really have to make a decision as to what could be done.
right. But again, I think, regardless, I think, scenario 3 for me, I think it's something we're really gonna have to, look at and figure out the best way to make it happen, because it really makes the system more usable for everybody. It's easier to operate, it's easier to use. I guess, what about fire flow for the hydrants in that school loop system? Is there a way for you guys to look at that flow if the blue tank is online?
Yeah,
Oh,
certainly.
yeah, definitely. Yeah.
Yeah.
Because we'll be going from a 200,000 gallon tank or 275 up at J Hammond to say, I know the tank on Route 20 is 750,000 gallons, but if you have it filled to the same elevation, I think it's like 660 or 670. So it definitely gives us a lot more reserve capacity for if there is a fire in that area, those hydrants can be used,
Yep.
right?
Yeah,
Yeah,
we
yeah,
run
yeah.
that
We
too.
definitely can look at that.
Yeah, sorry, I forgot to mention that earlier, so
Yeah,
that'd
no,
be great.
that's fine. So just to recap, if you don't mind.
Yep.
Pete, we'll add those estimated costs. Particularly with scenario 3, and then take a look at fire flows for that scenario.
Yeah, and directional flow water each.
Yeah,
Awesome.
And
It-
just my own knowledge, when we talk about operating the system and with sensitivity, that's even opening a hydrant fast or,
yes, yeah,
Oh, yeah. Yeah, or even having check valves within booster stations can really impact the transient. Like the rate of closure and opening, which would
Yep.
likely be triggered by VFDs and everything.
yeah. And so the reason for that, just so you know, and Pete's always kind of described the system as one long straw. You know, if you were to have a system that you would look at more as like a cobweb, right, or spider web with interconnections throughout, those interconnections are a spot that pressure transients can dissipate. And so where you don't have that, that's where you get the sensitivity that pressure wave begins to build and has, nowhere to dissipate. So that when we talk about sensitivity, that's why.
One of the other interesting things that we found in doing some pressure recordings at individual homes
Yeah,
is that the 1-inch service line off of the main is small enough that those transients don't get conducted to the home. So the residences, the homes off of this line aren't seeing the same transients in the house that the Bay Path pump station is because it has a 4-inch service line. Or that we see if I put the pressure sensor on the hydrant with the 6-inch feed line. So it's kind of interesting to see where, you're seeing these huge pressure swings at the pump station or at the hydrant. And I put it on a house that's maybe even at a higher elevation. And the only pressure spikes you see is when they shut a faucet off too quick.
right.
It doesn't coincide with any of the transients in the rest of the system.
Right.
And again, most likely because that 1-inch service line is too small to really
Right.
conduct it,
Or-
that pressure goes right by it.
Right.
So
Yeah,
I think
'cause
fortunate for us, right? Because otherwise all the homeowners would be having the same issue.
Yeah, exactly.
Yeah, no, yeah, that would be.
So. Well, excellent. Again, I'm glad we found hopefully a viable solution that we can implement somehow and make happen. And
Yep, I
again,
agree.
really get our system to a good spot to be able to continue to grow.
how
Yep.
long will it take the balance of this information?
None of this is really a heavy lift. I don't know if we can have it to you for your next meeting, if that's 2 weeks from tonight, but certainly.
Yeah, when is the next? Yeah.
May 9th.
Yeah, well, yeah.
Oh, if your next meeting's May 9th, I think we'll be able to do that.
Fantastic.
So what we would do,
Thank you,
similar to
guys.
this, we'd make these edits to this report, we'd change it to final or draft 2, whatever we want to call it, get it to you in advance of that meeting, and then have another discussion like this.
Perfect. Thank you, guys.
Great, thank you. I'm
Yeah.
gonna hang on just for Peter Newton's conversation, but I know Chris has
Yeah,
something
I'll be
else, so
heading
he's
out.
gonna
Thank-
drop off,
yeah.
but we appreciate it.
All right, thanks, Chris.
All right,
Thanks.
thank you.
Andy, make sure you ask Peter Newton all the tough questions, okay?
You will do.
All right.
We pre-gamed Peter. That's why how we got them all squared away.
Yeah, I'm sure you did. As long as you both look good, that's all that matters.
That's right.
That's
I'm
debatable.
wearing a button-down shirt actually for you guys tonight.
Look at that.
Hello, everyone. If anyone I haven't met, I'm Peter Newton. I'm working with Beta on the Santos property on the water, the source water supply component of your water system. And we have, just to give you a little bit of an update, if you haven't, you've gotten the summary I sent over to Peter. I guess it was last week. But so in FY23, we have, got off to a good start, but then we lost ground due to weather. But so we've got 2 wells drilled, well number 3, because we drilled 2 in FY22. Well 3, which is south of the conference center, along the access road to the other wells that we drilled in FY22. Unfortunately, it looked like a promising location, but got to 500 feet and they hit no fractures and they were getting no water. So we terminated drilling at 500 feet there. Now we know north of the conference center has their own well, which apparently pumps a lot of water, though nobody really knows exactly what that is. But unfortunately, it is only about 150 feet from the buildings. So it wouldn't have the setbacks required for a public water supply well. Probably doesn't have the setbacks required for its own uses, to be perfectly honest with you. But so we had to move. There's definitely some intersecting fractures to the, you go a little further to the north and west of that well. It's down a steep embankment, and we got Charlton Well out there, and they drilled, and it looked promising. We drilled that one to around 720 feet, and unfortunately, it was only pumping. They could only lift pump around 15 gallons a minute. Interestingly, when they terminated pumping and pulled all their equipment out of the well was flowing at the surface about 3 gallons a minute, 3 to 5 gallons a minute. So there's definitely water out there, and there's water under pressure there, but we're just probably not going to get anywhere close to 75, 100 gallons a minute out of that site, that particular boring. Now this is the challenge with bedrock wells as opposed to overburden wells, is you hit the fractures or you don't. We're doing our best with liniment analysis and the preliminary work to try to focus in on areas to drill. But if you're off by 5 feet, you miss it. And these fractures typically are fairly vertical, so you don't have a lot of wiggle room. If the fractures are more, on a 30 degree off a horizontal, you've got a lot more space to work. If they're 60 or 70 or 80 degrees from the horizontal, you really, if you're 5, 10 feet in the wrong spot, you miss it. If you go 5, 10 feet the other way, you get it. So unfortunately, we haven't had a great deal of success on the Santos property. So, I know there's water out there. We're just not having a great deal of luck finding it. So the next course of action under FY23 is we had budget for 3 wells. And so we're gonna, assuming once we get access to the Bay Path Road site, we're gonna mobilize Charlton Well out there to drill a test well, a location we selected earlier in this year, in the fall. So, so that's kind of where we stand. We do have budget for 1 more well. We do have budget to ream out a larger well. We just have to discuss how we want to spend that.
So to look at the Santos property, in order to really consider that as a viable water source and to implement it, we would have to cut off all water supply from Southbridge and pump that into the Route 169 infrastructure. which isn't a heavy lift, but we have to make sure that there's enough water there to handle the current water in our system and future growth. So to comfortably say we should purchase the property or any part of the property and develop the wells, we would need to see 5, 6, 700,000 gallons a day out of it so that we can, again, be comfortable to say that we can provide current water and future demands and not do this and then say, oh, sorry, we can't allow any new connections. So, I mean, Peter, for 500,000 gallons a day, and what's that for gallons per minute? 300, 400?
Yeah, well, it's 300 to 400, but typically we would size the, we would want 500 to 600 gallons a minute so that you don't have to run the well 24/7.
And again, unfortunately, we weren't able to find, I mean, the thought isn't to find one well at 500 gallons per minute, but maybe find 2 or 3 in that we could get 200 gallons a minute from and have them kind of go back and forth. So unfortunately, we weren't able to find that. The fracture that you've identified at Bay Path Road is different than the fractures that we were following at the Santos property, correct?
It is, yeah.
And then just to kind of touch on the Bay Path Road property a little bit. If that were to provide, we found 250, 300,000 gallon per day water source. We could use that to supply water to part of our system using the existing infrastructure that was installed on part of the Route 20 project, the original project and the original pump station. And we could separate our system so a part of it could still be supplied by the town of Southbridge and a part of it could be supplied by our own in-town source. And also it would be greatly beneficial to get water on that east side of town in Route 20. So unfortunately, the Santos property didn't work out yet, I guess, and hopefully, we get lucky at Bay Path Road and we can see what happens there.
All right. Anybody have any questions for Peter? All right. Mr. Newton, thank you so much.
My pleasure.
Great.
We'll keep hunting.
Thank
So
you.
again, we're gonna talk about that Bay Path Road property in executive session, Peter, and once we come
Okay.
out of that and hopefully I get some type of agreement, I'll let you know and we can get that going and get that done by the end of the fiscal year with that grant money.
Terrific. Terrific.
All
All
right.
right. Thanks, Pete.
Thank you. Nice seeing
Thank you,
you.
commissioners.
Thanks,
Thank you.
Andy.
Thanks, guys.
All right, take care.
Bye.
All right, guys, I'm moving on to new business, water privilege fee, 166 Worcester Road. We're gonna pass on until next meeting. So we're gonna move on to pump station monitors. Go ahead, Pete.
Yeah, so we currently have dial-up pump station monitors that will dial to the on-call cell phone that just gives whoever answers the phone an alarm code for, say, high level or whatever issue is programmed into it. I found some new equipment that will allow us to get more accurate data and monitor our pump stations with, again, a little bit better. So the new data, the new monitors work on the cellular single, and it will transmit real data to the cloud that we can have access to. And one of the best things about this is it's kind of two-part. For the pump stations that have generators, we'll be able to, it can alarm us when there's a power failure. And then we can also go online and we'll be able to look and make sure that the generator has turned on so that we'll be able to know that that pump station is still working. It'll also allow us to track pump run cycles and time so that we can use this as a way to help track our I&I. I talked with Paul Rodman about this and he said it could be, it'd be really beneficial for him to be able to take that data. And again, talking to the person that provides the monitors, he said we can set any type of alarm so that if that pump station, if the pumps turn on, say more than 12 times in one day, it'll send us an email saying that pump station ran more than normal. Or if it runs for more minutes or hours, in one day than normal, it'll send us an email or alarm. And it'll also call out for the same type of, high wet level and stuff like that. So it seems like hopefully they work as well as it seems. I do have a sample one that I took to most of our pump stations to make sure that there's cell service there, and it seemed to work at all of them but one. So I know in here I asked to purchase 6 units, and that was because I wanted to initially do the 6 units with the generators. However, I'd like to increase that to 9 units. That way there we can get all of our pump stations, but the Mugget Hill Road pump station with no service. And also we'll be able to really track the pump run times for flow monitoring routinely and get a good understanding of where the flow is coming from, hopefully in wet weather events. So our current system requires a Verizon landline that costs approximately $48 per month, or say just $575 a year. The new system has a one-time charge. It's like $999, which includes the unit and 3 years of cell service for the device. So it's like $499 for the unit and then $400 and change for the cell service. And then it comes with a small battery backup. So if there is a power loss, the monitor will still operate. So in the grand scheme of things, we'll probably be saving $500 over 3 years and hopefully getting, 100% more data that's usable to help us. So
This is for all that I, Pete, right?
it'll definitely help. Yeah, it'll get Paul Rodman more data, and it'll also get Vinny more operational statistics or more operational data on a daily
Yeah.
basis to help him operate the stations.
So that I line item, don't we approve like $25,000 a year typically for something for I, something like that?
So we carry $44,000 a year in there for the fiscal year. We just approved maybe 20 for Paul Rodman to get us through 6 months of flow monitoring with the 3 flow monitors that are going to be installed in different areas of the system. And if we get these put in, this will just give Paul Rodman a lot more data to really get you guys hopefully a comprehensive report of where to look at more than a narrowed down area to look at for I. And when you, again, not to bounce all over the place, but when Vinny was talking about working with the engineer for the headworks upgrade, we started looking at actual flows that we're seeing. And when Vinny talked about, designing for 2 million gallons a day, it doesn't make sense to over design the headworks building for 2 million gallons a day when nothing else downstream in our treatment plant is able to treat that. Nor should we have to, because we shouldn't be getting that type of flow. So that's when we kind of brought it back to say, let's just design the headworks upgrade to what we really need, not over design it, because we're not going to design the rest of the treatment plant to handle 2 million gallons a day when we're approved for 450. And let's really spend some time looking at the I and try and find the solution that way instead out in the collection system. So I think this would be a good start to help us. And again, in all reality, based on what we're paying currently for the landlines, we're going to save almost $500 over 3 years. So I think it's a good investment. We do still have funding in our FY23 I line item to pay for this. So I'd ask for $10,000 to be approved so we can purchase 9 of these units.
I'll make a motion. We approve the expenditure of the money for the units as stated.
Second.
No more discussion. Roll call vote, Peter.
All right, Mr. McLam,
Aye.
Mr. Coleman,
Aye.
Mr. Jennings,
Aye.
and Mr. Cantwell.
Aye.
Great. Thank you, gentlemen.
Moving on, old business, none. Other business, none. Next meeting. May
Next
9th,
meeting-
Peter.
Yeah, it will be May 9th after the election.
All right, somebody want to adjourn and put us into executive session, please?
Make a motion. We adjourn to executive session.
The motion has to be precise as it's printed in the agenda.
All
If
right,
anybody
let me
has
see if
that.
I bring that up. Hmm.
If not, I can, I'll just read it as stated, if you guys want to do that, and then make the motion accordingly.
Yeah, that would be great.
All right, so we're gonna
don't
go,
have-
we're going into executive session to discuss the purchase of property on Bay Path Road. The motion is to go into executive session under Mass General Law, Chapter 30A, Section 21A, Number 6, to consider the purchase, exchange, lease of value of real estate if the chair declares that an open meeting may have a detrimental effect on the negotiating position of the public body, and the commission will come out of executive session for the sole purpose of adjournment.
I'll make that motion as stated.
I will second.
All right, roll call vote, Peter.
Mr. McLam,
Aye.
Mr. Coleman,
Aye.
Mr. Jennings,
Aye.
and Mr. Cantwell.
Aye.
Great. Thank you, guys. All right, is there a motion to adjourn from open session?
I will make the motion to adjourn.
Second.
I got a second.
All right, Mr. McLam,
Aye.
Mr. Coleman,
Aye.
Mr. Jennings,
Aye.
and Mr. Cantwell.
Aye.
All right, and Cam, again, thank you for your service the past 3 years, and good luck with the new venture.
Thank you very much. I just want to say, this was a very overwhelmingly positive experience for me. I learned a lot, and I'm glad to have helped out in whatever little way I could, and keep Charlton great, guys.
Thanks, Cam.
Thank you, Cam.
Appreciate it.
Cam.
All right, have a good night, everyone.
Bye, guys.
Good night.